Now, my name is Wanadeza binti Saparan. Now I will present about introduction. In today, airline industry is discussed to present passenger number due to factors like holiday, global research, and economic shift. Important passenger data such as age, gender, travel, purchase, and certification are often ignored in business discussion without proper data analysis and predictive model analysis, risk of discussion, and financial loss. This study applies data science and machine learning to analyze passenger data, identify case certification factor, and classify many passenger into manifold groups. Now I will present about research question. First is what are the key characteristics of or attributes in the passenger profile that influence their level of sophistication with airline service. Second is three specific expenses or trends in the passenger data that can be used for prediction or classification purchase. For example, types of customer you are frequently disqualification. Second is how effective are machine learning techniques such as discussion tree and random forest in classifying the certification level of passenger or the travel segment. And the last is what's classification models provides the has actually in identify passenger category based on the demography data and feedback. And the next is objectives. Machine learning help find findings in passenger data like travel behavior and bookings, improving service and efficiency. Rapid manner makes the easy with even without coding. The airline industry drives the economy, but not all passengers want the same things. Forecasting demand helps with pricing, planning, and better customer experience.
The analysis and prediction of passenger-related metrics such as demography, travel behavior, and individual preferences have become increasingly vital in the transportation and travel industry. Variables include age, gender, travel frequency, and seating preference play a critical role in enhancing customer experience for improved operational efficiency and reinforcing safety measures. With the advancement of the machine learning technology, the capacity to process and analyze vast volume of passenger data has significantly improved. This technology have enabled higher predictive accuracy, more informed decision making, and the development of personalized service.
Hi, I'll be the next presenter and I'll be talking about the methodology. For methodology, there will be two phases, which is data collection and data preparation. First is data collection. For data collection, the data sets are from online repository that contains 129,880 records and 24 attributes. It includes the demographic, flight experience, and the services quality, and also the suitable for classification and exploratory analysis. And last but not least, the target variable that satisfied natural or dissatisfied. For the first two is data preparation. For data preparation, there will be data cleaning that handles missing values and duplicates. The transformation will be one-hot encoding for categorical data and normalization for numerical data. For the attribute selection will be key features that seat comfort, entertainment, cleanness, delays, and class. For the target encoding is satisfied for 1, neutral or dissatisfied is 0.
Thank you to Ms. Vetronella. My name is Nuratika Erilisa binti Abdullah and I will talk about the data preparation and exploration. In this phase, we import the data set into RapidMiner and ensure it was ready for analysis. We clean the data to remove missing values and transform categorical variables using encoding techniques. Key attributes were selected and the target variable is passenger satisfaction, which was set as a binary label to prepare for modeling. And we move on to the next part, which is exploratory data analysis. We then explore the data set visually. Female passengers had a higher satisfaction rate, while most passengers were within the 20 to 40 age range. Third class was the most commonly used ticket class. This pattern gave us insight into passenger behavior.
Next is 5.0, the build models and experiment. In this section, it is focusing on constructive, predictive models and conducting experiments to analyze, predicting and analyzing passenger measurement using machine learning dataset within this RapidMiner platform. This process involves using various data science techniques and tools to develop models that can effectively predict how different factors such as gender of passenger, type of seat, nationality, and ticket class is the 5.1 applying machine learning model. For this figure 9, this is the split data process of machine learning model. This step involves in utilizing a decision tree, applying a model, and validating the model using split data are illustrated. Split validation, a method of validating the model, is specifically applied in this context. The data is partitioned into ratios of 0.7 and 0.3 as a specific in the split data parameter list. The decision tree is trained using the 0.0 position ratio, while the model is validated using the remaining 0.7 ratio. For the figure 10 is the accuracy result, figure 11 is the precision result, and figure 12 is the recall result.
And we move on to the next part, which is experimental design. We designed 3 experiments to test how different settings affect model performance. The first used various splitting criteria, the second adjustment minimum leaf size, while the third changed steer depth. This allows us to identify the most effective model configuration. Next, the experimental result. Among all the models, DT5 achieved the highest accuracy at 86.22% with perfect precision. Other models like DT4 and DT8 to DT10 also perform well but with slightly lower accuracy. This consistency in result validates the reliability of our chosen machine learning approach.
This table shows the average rank result of our decision tree models. We can see that DT4 and DT6 to DT10 perform the best with an accuracy of 85%, which is at 100%, while recall is 79%. These models are the best choice for our profitability ratio analysis because they rank first in accuracy and precision and third in recall, it showing they are consistently and reliable for our analysis. Based on this result, these models are considered the best choice for our analysis as they consistently rank first in accuracy and precision and third in recall. This shows that these models are stable and effective for decision-making related to profitability ratio and evaluations.
In conclusion, using machine learning to study and predict passenger behavior can greatly improve how transportation systems work. These research show that RapidMiner is useful for analyze complex passenger data. It helps predict things like travel demand and preference, which allow companies to plan better and use resources wisely and offer better service. RapidMiner is easy to use, even for people with a strong programming skill and make a coding and using machine learning models simple. This shows how important it is to use data to make smart decisions in the transportation industry.